Okay, good morning everybody. So I'm doing this Sunday so that I can have this out for you. Plenty of time to review for the test. So I'm going to make a recording of the review and then we'll work on it in class if you're here in class. So number one, graph the function and its parent function. So I'm going to go through this kind of quickly, but that's okay because you can stop it, you can repeat and look at it again. So here we go. Number one, what I know about number one is a parabola, and I know that in this parabola it has a vertex at 4, -1, or -9. So I'm going to go ahead and just sketch in a parabola. I'm going to go to, since in vertex form, I'm going to go 4, 1, 2, 4, 5, 6, 7, 8, 9. I'm going to go 1, 1, 2, 1, 2, 1, 2, 3, 4. And then I'm going to have the same thing over here. 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll have this another point here. And the reason I'm doing the other point there is because there is a line of symmetry that goes right through the middle of it, okay? Boom, there it is. So this is my parabola. I also want you to see, though, that I want the parent function and the parent function. So the parent function, well, that's just the standard old parabola. And it looks like, let me get a pen that works. Parent function is plain old parabola. It is the y equals x squared, and it would be like this, okay? All right, there's number one. Easy, huh? Number two. So number two says that we want to let g of x be the reflection over the x-axis and a vertical shift of 1/2 followed by a translation of 5 of this graph, of an absolute value graph. So if f of x, so number two, is equal to the absolute value of x, then g of x is going to equal a 1/2, and we're going to go translation 5 units up, a 1 to the right, so I'm going to go 1 to the right, so I'm going to go opposite, -1, because it's the opposite, remember, opposite of the inside, and then followed by translation 5 units up, plus 5, and then finally it's reflection over the x-axis, so I'm going to make this negative. Okay, don't forget that negative. Okay, here's my answer. Domain and range. Well, let's just do a real rough sketch. We don't even do a beautiful sketch of it, but if I'm at 1, 5, 1, 2, 3, 4, 5, there you go. And what I know about an absolute value graph is going to look something like this and like this, okay? Domain's easy. How wide is this? Domain's forever wide, so domain is x equals all real numbers, but the range starts at the height of 5 and goes down. Y is less than or equal to 5. Domain, range. Okay, that's number two. Moving on. Number three, I have write an equation of this line in X-intercept form. So here we go. First of all, slope. I know intercept form. I'm going to go y equals mx plus b. I know slope is going to be rise over run, or the y, 2 minus y1. So let's get slope first. I'm going to go, looks like it's going to go from 600 down 200 from 1 to 5, which makes a -400 over a -4, or it seems like it's going down 100 for every year. So that's my slope. I'll go y equals a 100x. And then I'm not sure what the x-intercept is here, but I can figure that out. It sure looks like 700. If I used my formula and I plugged my any point, let's use 600 equals my 100 times 1 plus b. Sure enough, b is going to be -100. -1. It's going down, negative, there we go, my bad, -100. So it is 700, -100 plus 700. I like to rewrite as years and sales, so I'd go sales per year is going to equal a -100y plus 700. If you don't like y, put t for time, okay? Either of those answers, okay? Number four, moving on. A parabola has a vertex at -6, 12 and passes through 0 and -24. So on this one, what we're going to do is this. If it's a vertex, we're going to use vertex form for number 4. I'm going to go my y equals some a times my x minus h squared plus Okay, that's my vertex form. That's my hint. So then, what I want to do is plug things in. So I'll go, all right, here's my vertex. There's my h and my k. I'll go y equals a times an x minus a minus 6 squared plus a minus 12. Got double negative, right? And then if I want to find the value of a, so I use this 0.024. I'll plug my negative 24 in for y and my 0 in for x, and I'll solve. So my negative 24 goes in for y, and my x becomes 0, right? And then I just want to solve, okay? So first of all, plus 12 plus 12, I'll get a negative 12 equals a times a 6 squared, and a 6 squared is a 36. I'll divide by 36, and I'll get a negative 1/3 for the value of a. So I will put that back in there, and here's my answer. Okay, my answer is going to be a y equals a negative 1/3 times my x plus 6 squared minus 12. Okay? Hopefully you can do that on the test. Okay, now number 5. I already got the answer. I don't want to spend all period or this whole time going over, but you only have one of these. What I did first is I put equation 1 and equation 3 together. That actually seemed easier for me, and I multiplied this one because I want to get rid of the x's by a negative 2, and then from there I have to get rid of the x's again, and then put 1 and 3 together to get rid of the x's, okay? Anyway, that's the answer. Number 6, I'm going to graph this. Okay, that's not too hard to graph. We can do that. So on number 6, I got my paper. Try not to waste paper. So number 6, here's what I know about 6. All right, I know that it has a vertex. It's in vertex form of negative 3, negative 2. Okay, so let me put that in first. Okay, negative 3, negative 2. Put that in there. All right, and I'm going to go ahead and put my vertex at negative 3, negative 2. Vertex form opposite, right? Negative 3, negative 2. And then I would graph it normally like 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. But I'm going to make it half as tall. So instead of 1, 1, I'm going to go 1, 1/2. So 2, 4, I'm going to go 2, half as tall as 4. 3, 9, I'm going to go half as tall as 1, 2, 3, 4, 5, whoop, 4.5. There it is. And because it's symmetrical, I'll put my line of symmetry in there. So my line of symmetry is at x equals negative 3. And then I can reflect this point, and this point here. 1, 2, 3. There we go. And so I can graph that in, okay? Worst case, you can use a calculator to get these, but you can do these pretty fast by hand, okay? Now the vertex, I have that, line of symmetry. I have that, I've got the line of symmetry. Where does it increase? Well, it's increasing from negative 3 to infinity. And where is it decreasing? Well, all the way down from negative infinity to negative 3. Increasing, decreasing. Okay? Got it. I'm going to keep moving because I want to make sure that you guys have time to do this. All right, 7. So to take a look at 7, what I'm going to do is read it first. A bridge builder in town plans to construct a suspension bridge over the Wenatchee River, okay? The curve of the cable being formed will model this equation. So it kind of looks something like this, okay? If I just draw a picture, right? We got a bridge, it's a cable bridge, it's going to go something like that, right? So what I'm probably looking for is the vertex, right? At what height will the cable be close to the bridge? Probably the vertex, okay? So what I want to do is, since it's in standard form, I'm going to use my negative b over 2a. All right, so I'm going to go negative. Here's my a. There's my b, and there's my c. So I'm going to negative b. So I'm going to go negative 0.2 over 2 times 0.002. And I'm just going to use my calculator. It's much easier to do that. So I'm going to go ahead and go my positive 0.2, right? Positive divided by a parentheses 2 times my 0.002, and I get an answer of about 50, okay? So this is what it tells me. Right here is 50 feet, because that's my x value. So to get the height, I plug the 50 in, okay? 50 feet is right there, okay? So I plug the 50 into my equation for x, and I'll get the height. So, okay, I'll have h of 50 equals, and I'll go 0.002 times 50 squared minus 0.2 times 50 plus 60, and I'm going to plug that in my calculator, see what I get, okay? So I'm going to go, okay, clear that. 0.002 times 50 squared minus 0.2 times 50 and plus 60, and I get an answer of 55, okay? So that means the height here is 55 feet. Okay, there you go. All right, number 8. So what I'm going to do on number 8 is, first let's read it, and then I'm going to make a graph of it and look at the graph, okay? All right, the table shows the number of toy bears the manufacturer can sell at different prices, okay? The quadratic regression equation, how many bears would sell at $9? So first let's figure out what let's first get an equation, okay? So if I'm going to get an equation, I graph this, right? And bears in thousands, it's my price. 1, 2, 3, 4, 5, 6, 7, right? 3, 4, 5. And the prices, I'll do my little squiggly, and I'll do my 100 here, 120 maybe, 130 maybe. So I'm going to get these points. I'm going to get 3 and 112, about there. 4 and 125, 4 and 125, maybe right about there. I'm going to get 6. 5 and 132 is about there. 6 and 133. 6 and 133 is right about there. 7 and about 128, okay? So what's happening is this. What's happening is probably, like anything, that the lower the price, you can sell a lot of beers, but you're not going to make any money because you're going to lose money because you're selling too many and it costs too much. If you make the price too high, nobody buys your beers. So our vertex of this is at, looks like it's 5.5 or $5.50, and seems like it's about at 135, right? If you look here, you have 135, okay? So here's what I'm going to do. We're going to take vertex form. Y equals our a times x minus h squared plus k. We're going to go y equals a times, I'll put in the 5.5, x minus 5.5 squared plus 135. Okay, how am I doing? Okay, now the next thing I'm going to do is find this value a, so let's pick a point. Let's pick this one right here. It seems like the best point to pick, which is the 3 and 112. That's my 3 and 112. So I'll put 112 in for y, and I'll put a, and I'll put the 3 in for x, plus 135, okay? So let's solve for a, okay? Minus 135, minus 135, so 112 minus 135, and I get an answer of negative 23 is equal to a times, let's see, what is that? That is 3 minus 5.5, and I'm going to square that. I'll show you how to square that, okay? So that's a 6.25. Divide by 6.25 is the value of a. So clear this, what is negative 23 divided by a 6.25, and I get an answer of about negative 3.68. Alright, so let's look at our equation. Okay, so let's put this a back in up here. I have a y equals a negative 3.68 times my x minus 5.5 squared plus 135. Okay, there we go. Now, there's my equation. Let's see what the next thing asks. So it says, what would be the best price? Well, the best price has got to be, we think, $5.50, right? Because that's what we thought the vertex was. So we think the best price is $5.50, because at that point, we're selling the most bears. So we're going to say our best price is $5.50. Okay? All right. Moving on. Number 9. And number 9 is not that bad, okay? So we've got a company, and we want all of a sudden to increase our prices. So we're going to do a couple of things. Here's our f of x, and let's create a g of x, okay? So cars and miles can be modeled by this equation. After policy change, $8 more are added on. So I'm going to add 8 right there. So I'm going to go plus 8. So I'll have and then I'm going to multiply the whole thing by 1.3. So I'm going to go 1.30 times 0.45 m plus 13. I got the 13 by adding the 8, okay? If I wanted to simplify that, which would be a good idea, I'll multiply that times that. I'm going to go 1.3 times 0.45, and I get an answer of 0.585, so about 58 cents a mile, plus, what's 13 times 1.3, and I get an answer of about 16.9, which would be my, cleaning fee or whatever it is. Okay, there it is. So we'll go through this in class again, but that's it.